Hi. In this video, I'll be talking to you about the logistic regression classification. Like linear regression can also be used for the classification task, but there are certain limitations because somewhat there's a relation with the probability. In linear regression, the probability can go in negative, so we come up with some function which can limit the probability between 0 and 1. So there comes the concept of logistic regression. What logistic regression does is it fits a regression curve where y is a categorical variable between certain predictors. Like there was a function in linear regression, y is equals to alpha plus beta x. What logistic regression does, it transforms this function into a probability function in which this total line equation comes in e to the power something. So the total equation like becomes e to the power alpha plus beta x upon 1 plus e to the power alpha plus beta x. Sorry, and this thing is in e की power something. So this is the probability function of logistic regression thing. So this will limit the total probability between 0 and 1. So this logistic regression as a whole can be good for binomial classification also, and as well as multinomial classification also. Whereas the linear regression was only good for binomial classification, it like turns bad in the case of multinomial classifications. So we have two types of binomial logistic regression, like two types of model, like binomial logistic regression, and another is multinomial logistic regression. So we have an example of binomial like spam or ham. Earlier we have seen this, and another is like a typical example for this multinomial logistic is like we have to classify between entertaining, borderline, or boring the films are. So this is a typical overview of the logistic regression model. Like earlier in the naive Bayes also we used the Bayes theorem as a principle. In KNN we used Euclidean distance. In linear regression we use the regression principle. So here in the principle used is of maximum likelihood estimation for the estimation of alpha and beta parameters. So this thing is actually very tiring to calculate by hand. So this R has provided an inbuilt function, GLM function, which is very easy. Just you write the command GLM and it actually automatically gives you the parameters. What it does is like it multiplies the probability such that the curve fits best for that for that set of observations. One thing also like I want to tell you is that after this, like this is a simple approach. Like we create a data set, we just put this data set into a model, and using the test data set we predict the result. So after we have like trained the model using this equation, like using the logistic regression model, we'll put this some test data into this model, and using this test data we'll obtain some probabilities between 0 and 1, like 0.1, 0.3, 0.8, 0.25, 0.7. So we can just set a threshold, like if this is less than 0.5 we can do it to 0, or if this is greater than 0.5 we can do it to 1 for this binomial classification thing. For multinomial we can do some certain intervals like 0 to 0.25 for some classification, 0.25 to 0.5 for some. Similarly for rest of the things we can do like this. Before proceeding to the fitting process, let me remind you how important is cleaning and formatting of the data. The pre-processing step often is crucial for obtaining a good fit of the model and better predictive ability. Likewise, I told you earlier that this cleaning and formatting of the data is very important, because if you don't clean your data properly, the data which you will train the model with will be incorrect, and so the results will be. and if the data consists of more number of NA values and all the blank values, then there will be like not accurate training for the model, so it will not be able to predict the results based on its past, which is the model. So this there will be some error in the results. So better is to take precaution and just clean and format the data, and also observe the data which you are dealing with, because after observing only the data you will be able to realize which classification or which prediction algorithm or model you will use. For like a linear regression, like you have to predict, so you will use linear regression. For classification, there are several models I have referred here, like Bayes, Naive Bayes, KNN, and this is Logistic. So just be precise by studying the data which you will be using for the classification, for training the model, sorry. So let's move on. So here's a simple code. What data set I have used here is like of Titanic data set. This is train.csv. I have downloaded this train.csv from Kaggle. So just go and search, you can easily find it. I have stored this data set in training data.raw. Then what I have done through this function is like I have used an sapply function, which is simplified version of lapply. I have applied this function on training data, and what I have done, I have just created a small function in one line. What it does is it just total sums up all the NA variables in this data set for each column. So what the result will show, like this data set will consist of number of NA variables in each column. So this is a simple line. Then I have called a Amelia package. Amelia package is like very useful for observing the data. It consists of a mismap function, which will map the total number of NA variables in visual format. Like after running this command, you will see the output of this thing. So there are several features here you can see. So you can see that this cabin thing consists of a lot of NA variables. Like this white thing shows missing and red is these are observed. So cabin is like showing a lot of missing variables. So instead of training with this feature, we can actually exclude. And also this cabin feature doesn't make sense. Like the data set is all about whether in the Titanic crash the people survived or not, depending on these set of features like age, sex, fare, ticket, P class name. So this is the concept of this data set. So this cabin thing doesn't make sense in this, so we can actually omit this. And likewise for age, we have so many these missing values, but we can't omit these values, because age is actually making sense for prediction thing. Like if a person is aged, he might have survived, or if a person is younger, he might not have. So age is a good feature variable to train the data with. So what we will do, we will just take the mean of all the data actually present and just replace the NA values with that mean value in all these things, so that we will have no NA values in these. Similarly for embarked, we can just remove, as we can see there are only 2 NA variables, so we can just remove these values. So in this, what I have done, I have taken a data which is a subset of training data, and I have selected 2, 3, 5, 6, 7, 8, 10 and 12 columns. As I said earlier that I'll omit this cabin, so this is the first column, so I omitted it, and I have trained the total data set with 2, 3, 5, 6, 7. Then what I have done, I have this is simple. What I have told earlier, I am replacing the age elements which had NA values with the mean value of all the variables which are actually present there. So also I have removed the embarked elements. Now what I am doing, I am training the data set. I have splitted the whole data set, which consists of 889 observations, into 2 parts. First is train, then is test. I have taken 800 rows for training and 89 for testing. Then I have used the model GLM. GLM is generalized linear model. What I am doing here is I have used the class as a survived. Survived consists of two variables, 0 or 1, means it the person has survived or a person has not survived. So I am just training the model using a predictor variable, using a predicted class survived, and using features as the independent variables. And I have used a binomial logit family. Binomial is for the class, like I have only two classes here, so I have used binomial, and logit is for logistic. Then I have provided the data equal to train. Then I have called a summary model function. What it does is, like, I have trained the model, and I'll by calling this command I'll get the result as this thing. So what it tells me, like, these are the features and these are the estimates. Like, I have the logistic regression equation, alpha plus e की power alpha plus beta x1 beta plus beta x2 and all these things. So what it tells is that these are the slopes, but that how by how much amount these features affect the class. So, and these star things are like telling which features are actually playing role in this classification, like Page, Fair, Embarked, Q and Embarked S are actually not fruitful for this classification, so we can just neglect them and train again the model excluding these things. And these, like, intercept is good, but actually it's not important. Then P class, sex, age, and SIB, SP. So age, what does this thing minus 0.037267 says? So what does this age thing tells me? Like, age consists of two categories. Age is like lower and older age. So age tells me, like, there's a negative coefficient in this. So what it tells me, like, there is less chance of surviving for the older persons than younger persons. Similarly is for sex, like this is for sex male coefficient, sex male category. There are two categories in sex, male and female. So what it tells me is, like, there is less probability of a male passenger to survive in this Titanic crash. So these are really very useful for predicting the results. These are the standard errors, these are Z values, and these are PR values. These are actually very useful. Just study and just get a grasp of these things. And after I have trained my model, now what I'll do is I'll get the results using predict command. I'll put the model in the predict command. I'll use the dataset like this only, and I'll provide the test dataset. Then I get the results. The results which I get will be the probabilities in the range 0 and 1. So I have assigned a threshold that if the probability is greater than 0.5, then just assign the fitted results vector with survived, else not survived. Then I am calculating the misclassification error using mean function. This is simple. Then I am just printing the accuracy using 1 minus misclassification. So I am getting accuracy of 0.84. So this 0.84 is actually very good, but this keep in mind that this result is somewhat dependent on the manual split of the data that I made earlier. Therefore, if you wish for more precise score, you would it would be better of running some kind of cross validation, such as k-fold cross validation. Okay, so this is the end of the logistic regression tutorial. Before ending this, I'll like to advise you, just there are only two concepts. First is just clean the data and just train the data. So for cleaning the data, I have shown you various tools, like just use the str command or summary command, or using this Amelia package, and just observe the data, because after observing the data only you will realize what algorithm you will be going to use. Then another thing I'll like to tell you is that after you have obtained the data, you are going to train the data to a model. So before training, just see that actually the data you are training the model with is like random or just in a sequence in a particular order. Like if it's in a particular order, then it will not give you correct results. So just randomize the total data in the data set so that you can train the model better. Okay, then thank you.